you. Hello, everyone. Thanks for taking some time and attending the presentation. I'm Antonio. I'm a software engineer at KILT Protocol, and I'd like to talk about DIP, or the Decentralized Identity Providers, and how they come together with state proofs. So for those that were decoded a few months ago, the first part of the presentation will be very similar, explaining what DIP is and what problem it solves. The second part will be different because we have made some progress since the time we talked to decoded. So before explaining what the DIP is, I'd like to trace a very brief history of how identity management has changed over the years. In the 90s, if you are old enough, you would have different services and you would have to configure different accounts for each of the services. Maybe 3 different email addresses, 3 different passwords, or the same password everywhere, with all the implication that has. The natural development 20 years later, so in the 2010s, was to improve the user experience by somehow centralizing account management or identity management. And this apparently represented a win-win situation for both the users and the services. Because on one side, the users would have only one identity to manage, so one email address, one password, and the services would have less liabilities because they would rely on a trusted third party to manage identity, and also, of course, less things to protect because they don't have a password database anymore. So over the years, several different names and iterations have been developed for basically giving different names to the same concept. So the most recent protocols are called OAuth and OpenID. And OAuth deals with user authorization, and OpenID deals with user authentication, which has been the main inspiration for the DIP protocol. So the OpenID protocol is composed of 3 different parties. We have the end user at the bottom, we have the identity provider, for instance, Google, and we have relying parties, for instance, Discord or the Zoom app. So the way it works is very simple. As a user, you go on the identity provider, you do the authentication exchange, you get an identity token back, and then, which is, of course, digitally signed by the identity provider. And then you go to the third parties, for instance, the Zoom app, and you basically show the identity token, which has been signed by Google. Zoom app knows what the certificate of Google is, and they can verify the digital signature. But because the information is sensitive, so the way, like, all the information that is associated with my Google account is sensitive and also only, let's say, established between me and Google, Zoom has no way to verify themselves whether the authenticity of this information is actually true or not. They have to trust Google that whatever Google is saying is true about me. So this definitely does bring convenience on one side, but we've also seen that this basically shifts all the power in the hands of few identity providers, which are highly centralized, both in terms of the control of the information that is shared, and also on the amount of data that they collect, because now they have basically insights into any application that I'm trying to access, because for each application, I would have to go on Google and say which application I'm trying to use. Moving on to DIP, the representation is very similar to the one about OpenID, because exactly that's what we're trying to do, but bringing it into the Web3 world, and that's what DIP is about. It's a decentralized identity provider. So the naming is not really original, but it gives away what it does. It's a protocol that enables a user to have their identities in a single place and use them in multiple different locations, but without sacrificing usability and decentralization. And we wanted to retain, for this reason, the same naming as the OpenID protocol, namely the identity provider and the relying party. So yeah, similar to the OpenID protocol, the first step for a user is to set up their identity on the identity provider chain, for instance, on KILT. Once the identity has been set up on the identity provider chain, the user can then start using this identity and interacting with all the different consumers without having to every time interact with the identity provider anymore. So this is the key difference between the traditional OpenID protocol and the decentralized version of the OpenID. Of course, because it's a protocol, it means that anyone else that has some kind of concept about identities can also act as an identity provider. We're not trying to gatekeep it here. So for instance, our colleagues from Lit Entry can also basically become identity providers and offer such a service to their user user base. And the process would be the same. What just changes is the way that identity is represented for lit entry, which is probably different than the way that KILT deals with identity. So KILT envisions as being an identity. Yeah, so after that, if a user has a deep identity set up on lit entry, they can go on consumer chains that basically trust lit entry as a truthful identity provider, and they can just use it right away using the same basic protocol components. So yeah, of course, on the side of the consumer chain, for instance, the frequency chain, they can choose to integrate more than a single identity provider. So it's not just one identity provider serving multiple chains, but it's one chain potentially tapping into the user base of different identity providers, basically for free, building on the user base that each provider has already built over time. Yeah, so for instance, a frequency chain can have, Polkadot identities. If Polkadot becomes an identity provider, they can have KILT identities, they can have lit entry identities, or inside the same parachain runtime. So this is where the presentation diverges from what was presented decoded. A few months ago, we envisioned a way for DIP to work over XCM and HRMP channels. So the legacy architecture is that the provider and the relying party would open an HRMP channel with each other, or at least from the provider to the relying party, so that messages can flow from the source chain to the destination chain. And then for a user to bridge that identity, they would have to call an extrinsic on the provider chain, specifying which destination they want to bridge that identity to, and also how they want to pay for the XCM fees. And the reason why this has to be repeated for each relying party chain is because right now XCM doesn't support multicast messages. So you have to send one message to each chain that you want your identity to be bridged. And then, of course, there's a palette on the consumer chain, which on the provider chain, which takes care of aggregating all the different identity pieces of a user, again, depending on what concept of identity the source chain has, and then bundle it into an XML message, send it to destination, and paying for the fees that the user has specified. One strong limitation here we found is that it's not really trivial to deal with XCM fees when you want the parachain to be the origin of the message, but you want a user on that parachain to pay for the fees. This is hopefully solved with XCM before and with clear origin instruction, which allows you to exactly do that. Go down at the user level, withdraw some fees, then go back up to the parachain origin and do some operations as a parachain. Because as a relying party, you trust the source parachain, you don't trust users on that parachain. Yeah, so and once the identity has been bridged to destination, so once this message with the identity aggregation has made its way onto the relying party chain, then there's a palette deployed on the relying party which takes care of validating all of these identity proofs that the user submits when they want to act as their identity on the provider chain. The format of this proof is, of course, depending on how the identity provider envisions such proof to be built. So it can be different from each of the identity providers. And of course, this palette, once verifies that the proof is correctly generated, then it dispatches the call that the user wants it to dispatch initially. And this is the dispatch as extrinsic, where you give the identity that you're trying to use, the proof, and then the actual call, runtime call that you want to dispatch. The new version, so this is now we're talking about the current version of the DIP protocol. It's still implemented by two palettes, but they don't assume that there is an HRMP channel open between the two parachains, but the two chains interact with state proofs. They're also called storage proofs. And then we can call this state proof-based communication channel a truth link because there's no way to basically generate a wrong state proof that would still be considered valid. The commit identity extrinsic then is still the same, but because we are not sending anything to a destination chain, it just takes the identifier of the subject. The commitment, this identity aggregation, is there somehow generated and stored on the identity chain, and the user can now use it on any other chain that somehow has a view into the storage of the state of the provider chain. The upside here is that compared to the XCM version, there is always at any time a single view of the identity information. There are no different copies on different chains, which means that they cannot get out of sync with each other because it always only lives on a single source of truth. And then, once the identity has been committed on the provider chain, the user can directly go on the receiver chain. There's no XM involved, and they can just call the same extrinsic dispatch as they provide a proof, which is, of course, different than the proof that was developed with XM-based messaging, and then the call they want to trigger after the proof has been successfully verified. And then, because the identity has been bridged, the user doesn't have to go through the provider every time they want to do something, so they bridge it once, and then they can use as many times as they want on either consumer or relying party parachains. And it's guaranteed that information is always fresh because it stays on storage. It's based on storage proofs. So we can see that different parachains can access the same information about the subject once the identity has been committed once on the provider chain. That also includes the Polkadot relay chain. I'm going to demo how that can be done later. And of course, also more ecosystems can be bridged. Beefy will make bridging way easier and more efficient. This is yet not implemented, but we are working on this after we release the first version of DIP, where you could basically do the same. Instead of calling an extrinsic on a parachain or a relay chain runtime, you would call a transaction on an EVM-based chain. The rest of the proof mechanism would basically be the same. And there would be a smart contract and not a pallet verifying such proofs. What are the advantages of DIP? Well, the identities become portable, so you don't have one identity per application, as used to be the case with Web 2 applications, but you have one identity that can be used in many different applications. The chains can do what they do best, delegating identity management to chains that do that for a living. And as I said before, the identity lives in a single place. That means it doesn't get out of sync. You don't have to take care of updating in many different places, but you manage it once in a single place, and then the changes are reflected pretty much everywhere you want to use your identity. And identities become decoupled from accounts. So we move away from the paradigm of a single blockchain account representing an identity, and we move more into a paradigm where an identity is represented, in our case, by a decentralized identifier, which lives on a abstraction layer higher than the blockchain level and blockchain account levels. So how to become an identity provider? Well, it's very simple. There is a outstanding pull request now in our repository. We are still working on a few pieces before we can deploy it on testnets. Again, if you are an identity provider, you probably have to define what an identity looks like for you and what an identity proof looks like for you. And if you are a consumer looking to basically use identity providers, you should also know what information the identity provider makes available for you as a consumer chain. And then you would take the DIP provider palette, which is, again, a self-contained palette. You customize it with your own identity primitives, and then you just deploy it on your own chain. And then you basically customize or provide a customized version of the consumer palette that other parachains can just grab, deploy into their own runtime, and then start using your identities right away. And I will show how that's done. So how do you become a relying party? Well, you take the consumer palette, which some identity provider has somehow customized and made available for you, and of course you choose which identity providers you want to use. You deploy a second palette, which is the relay store palette, and this is right now basically necessary to keep track of what were the last n state roots of the relay chain on your parachain, because it gets overwritten every block. So if you want to somehow support proofs that go back 5-10 minutes in time, you need to have that palette. And this is how, well, it's not very readable, but this is how the provider palette looks like. You have an origin filter, so you can specify which calls can go through the DIP protocol and which calls don't really care about DIP. You can specify what is the type of your identifier, what is the format of the proof. That, again, agnostic over the protocol. It's up to the provider to specify what the proof looks like, how you store identity information from user in your own chain, and what is the logic to verify such proofs. Usually the verifier and the proof format go hand in hand and are provided by the identity provider. And that's just the config trait for the relay store palette. You just have to provide how many blocks in the past you want to store for the relay chain in your parachain. So KILT, of course, will implement the provider side of the DIP because basically we don't want to gatekeep it, and everything we do is industry and standard compliant with the latest development. We have DIDs, which is a W3C standard for decentralized identities and identifiers. We have Web3 names, which is like aliases, user-friendly names for those DIDs. And also, as of a few weeks ago, you could actually use a Web3 name to send any sort of tokens that a user has published under their Web3 name. And also, we have support for linking multiple different accounts, both from within the ecosystem and also EVM chain-based under your DID, so that basically authorizing your DID could tap into all of the different accounts that you own on all the different chains. And now you can see that with a KILT identity, you can not only log in into Web2 and Web3 apps, because we do support login with your DID, but you can also attach identity information to transaction directly to blockchain runtime. We see this could be very beneficial for use cases, for instance, governance participation or fulfill KYC requirements if you're interacting with a DEX. Or for accessing operations that are NFT gated. You can prove ownership of an EVM account that owns a specific NFT. You can access the features that are NFT gated. So why would a project choose KILT as an identity provider? Because we do DIDs and VCs. They are W3C standards, and they are the same across all the world. All the different projects that do identity, they mostly do the things that we also do. It's pretty easy to integrate the KILT stack. Well, you can challenge me on that if you try. We can talk later. Yeah, so there are a few standards which are native supporting DIDs. For instance, SIOP2 and OIDC. There are ways to basically integrate DID into existing OpenID flows. So a Web2 OpenID, which is the de facto authentication protocol, you can now use a DID, a KILT DID, to log in into those flows, basically out of the box. And yeah, and also now in blockchain runtimes and smart contracts with the DIP protocol. And yeah, so I'd like to give a quick demo if time allows. Yes, we do have some time. Oh, where's my? Yeah, so for the demo, I have set up a local environment that is a local Rococo relay chain. There's which is this one. There's a local instance of a KILT parachain, KILT Peregrine, which is our testnet runtime, which is, of course, connected to the relay chain. And then there's a consumer parachain. This is a dummy parachain which has, well, besides the basic system palette and basic utility palettes, it has a palette that allows anyone that is identifiable by a Web3 name, whatever that is, to post some on-chain messages for other people to like or comment. And these are the dApps here. So there are two different dApps deployed. One is connected to the relay chain, so the relay chain also has the same palette, so it allows people to comment, like, and post on the chain. And then there is a second instance which is deployed on the sibling parachain. So we have the provider parachain, which is a KILT parachain. We have the relay chain, which of course takes care of finalizing the blocks, and also if you want, for some reason, you can interact on the relay chain, and then you have a sibling parachain as well. And then there's the Sporon wallet, which is the wallet that KILT has developed and that deals with DIDs and VCs. So what you could do as a KILT user, if you have a DID and a Web3 name, which I can show here. So I have two identities with two different DIDs. One has the NTN X2 Web3 name, which is also my actual Web3 name on SpiritNet, and then another identity which has the NTN X3. Yeah, okay. So now I choose my identity. This is the relay chain. So I can go on the relay chain. I can set up my identity for usage with KILT. What that means is I select which identity I want to bridge. I will sign this operation. Oops. Okay. So what this operation does, soon enough. Yes. So now I have basically aggregated my identity on the KILT chain. So there is a representation of my identity, which in our case is a Merkle root of different bits of storage entries under one Merkle root. Now, because I have committed it on the KILT chain, I can be under my NTN X2 Web3 name, so one of the two identities that I have. I can now go ahead and use it directly either on the relay chain or on a sibling parachain without requiring much more of configuration. So I can go here, and I can say, hello, this is me. I can post it. So this is the relay chain dApp, basically, the dApp connected to the relay chain. And again, I can sign the operation with my DID. And if we go on the relay chain, we see that, yes, so I have posted. This is my Web3 name. The relay chain doesn't have the DID palette. All of this information is somehow breached by me, by the wallet user on the relay chain. And without doing any other setup step, I can go on the other dApp. So this is a sibling parachain. It's not the relay chain. This parachain also doesn't have any knowledge of, well, doesn't have any palette deployed, but it does know that it accepts KILT as an identity provider. I can go here and I can say, hello, it's still me. And I can do the same posting, basically. I can still select my identity. I'm not bridging it again because I already bridged it once. And I can, oh, yeah, OK, yes, that's the right identity. And it's going to appear here in bear with me. It's happening. OK, let's try again. That's the right identity, yes. OK, now it's been created. It will show in the dApp here. So I've used my identity, basically aggregated on the KILT chain, to use it for any other parachain that it somehow has understanding of what the KILT chain is, including the relay chain. Now, as an exercise, I could also go on the sibling parachain dApp. I can reload the page. I can try to bring my other identity now into the picture. I want to start using my second identity. So I'll select the second one. I will, again, aggregate it on the provider chain once, because I haven't done it yet. So we can see here that the next identity will be committed. Yes. So I'm committing this identity. Of course, I have to wait a few blocks because proof only work on finalized state. So now the proof has been, the identity has been committed on the provider chain. I have to wait 2 more blocks on the provider chain before it gets picked up by the relay chain. And also the state is finalized and communicated to the other parachain, because I want to communicate with this parachain. And this parachain only deals with finalized state, basically. So I can actually wait a few more blocks. I think 1 more should be enough. Yes, and now with my second identity, I can, for instance, like the post that I've done myself, like this. And what the wallet does in the background is basically composing this proof so that this parachain runtime can verify my identity information. I'm revealing only parts of my DID document, the parts that are relevant for this operation to be authorized. Yes, so the new like is there, and now we will show here. In 1 second. Yes, so I liked it, and of course, I bridge it on this, but I can go back to the relay chain, and I can also answer the other comment in the same fashion. Yes, and yeah, this is much more scalable because you have once commitment and then you can use it pretty much anywhere. And of course, if you change, yes, it went through. And if you change your identity on the provider chain, like if you add a new DID key or you add, I don't know, you link a new account and you want the change to be reflected on the other chains, you just have to recommit your identity, wait 24 seconds for the block to be finalized, and the new latest state is available to all the other parachains. So there's no out-of-sync information. There's no different copies to keep basically to have to manage. It all lives in the single place, which is the KILT parachain. And if I now go back to the slides. I think it's over. Yeah, right on time. Thanks for your attention. And if you have any questions, we don't have time now, but you can reach to the KILT booth. And please participate into the PR on GitHub, and we can drive this forward. Thank you.